Okay, you studied about preparation of potassium dichromate. Now, next concept is properties of potassium dichromate. Potassium dichromate is an orange red colored crystalline solid. It is sparingly soluble in cold water but readily soluble in hot water. Next property is action of heat. On heating, it decomposes to give potassium chromate, chromic oxide, and liberating oxygen. That is, potassium dichromate gives rise to potassium chromate, that is yellow colored potassium chromate, K2CrO4 plus Cr2O3 plus 3O2. Next property is action of alkalis, that is interconversion of, or we can say interconversion of chromate and dichromate. See, when orange red colored solution of potassium dichromate is treated with alkali, an yellow colored solution of potassium chromate is formed. That is potassium dichromate, which is yellow in color. On treating with an alkali like KOH, it gives yellow colored potassium chromate. This yellow colored potassium chromate, again this on treating with acid, it again the orange red colored potassium dichromate is formed. That means potassium dichromate and potassium chromate are interconvertible by changing the pH. That is, when alkali is added to potassium dichromate, potassium chromate is formed. On adding acid to potassium chromate, again potassium dichromate will be formed. That means potassium dichromate and that is dichromate and chromate are interconvertible by changing the pH. These the potassium and the chromate and dichromate ions, they exist in equilibrium with each other at pH is equal to 4. Therefore, that is on adding on adding base alkali to potassium dichromate, that is on increasing the pH, the H plus ion concentration decreases. So the reaction shifts towards right direction, equilibrium shifts towards right direction, forming potassium chromate, yellow colored solution of potassium chromate. And on adding acid to potassium chromate, that is on decreasing the pH, the H plus ion concentration increases. So the equilibrium shifts towards left and potassium dichromate, that is chromate ion, orange red colored chromate ion is formed. So from this equation it is clear that potassium dichromate and potassium chromate, that is dichromate ion and chromate ion exist in equilibrium with each other at pH 4. They are interconvertible by changing the pH of the solution. So next property is oxidizing property. Potassium dichromate is a powerful oxidizing agent in the acid medium. That is, in the presence of dilute sulfuric acid, one molecule of potassium dichromate provides 3 nascent oxygen atoms required for oxidation. So this in presence of acid, that is potassium dichromate reacts with acid to give potassium sulfate, chromic sulfate, water, and providing 3 atoms of nascent oxygen which are required for oxidation. So or we can write this ionic equation. If we write dichromate ion Cr2O7 2- plus acid H plus 14H plus plus 6 electrons gives rise to 2Cr3 plus 7H2O. So in this balanced equation, see, equivalent mass of potassium dichromate we can calculate by using the formula molecular mass divided by 6. Molecular weight divided by number of electrons transferred or number of electrons gained. 6 electrons. So molecular mass of potassium dichromate is 294 divided by 6 is 49. So equivalent mass of potassium dichromate is 49. So from this equation we see that dichromate ion gains 6 electrons. So since it gains 6 electrons and reduces to chromic ion, that is Cr3 plus ion. So here, since it undergoes reduction, it acts as an oxidizing agent. Some of the oxidizing properties of potassium dichromate are, it oxidizes iodides to iodine. That is, it oxidizes potassium iodide to iodine. Equation: potassium dichromate K2Cr2O7 plus 7H2SO4 plus 6Ki gives rise to 4K2SO4 plus Cr2SO4 thrice plus 3 iodine I2 plus 7H2O. So it oxidizes potassium iodide to iodine. Next reaction is it oxidizes ferrous salts to ferric salts. So it oxidizes ferrous sulfate to ferric sulfate. So the equation you are seeing, K2Cr2O7 plus 7H2SO4 plus 6FeSO4 gives rise to K2SO4 plus Cr2SO4 thrice plus 3Fe2SO4 thrice ferric sulfate plus 2H2O. Here the solution turns, orange red solution turns into green due to the formation of chromic sulfate. Next oxidizing property is it oxidizes hydrogen sulfide to sulfur, yellow precipitate of sulfur. So equation K2Cr2O7 plus 4H2SO4 plus 3H2S gives rise to K2SO4 plus Cr2SO4 thrice plus 7H2O plus 3S. So yellow precipitate of sulfur is formed here. Next is it oxidizes stannous salts to stannic salts. So dichromate ion Cr2O7 2 minus plus 14H plus, that is 7H2SO4, that is we can write 14H plus 3SN2 plus stannous ion gives rise to 2Cr3 plus, that is chromic ion plus stannic ion, that is 3SN4 plus 7H2O. So here 2 times 3SN4 plus is written, but it is plus. The product here is 2Cr3 plus 3SN4 plus 7H2O.